So here we've got 2.1.3. So this is the next section. We are going to split it over 2 days. Again, this is all about slope. This whole section is about slope. So if you take a look at the very top of this, the thing that I have highlighted is stuff that we had already identified from last class. So last period when we saw each other yesterday. But it's all the different variations or names that slope could take on. So we know that slope is the vertical change over the horizontal change, which we know is rise over run, which we know is the up-down portion over the left-right portion, which we know is the change in y over the change in x, which we have a fancy formula for, which we're going to use later. And we know that another name for it is m. So if you take a look at your images sheet for today, again, attached to the agenda, you've got these 4 blank graphs. What we want to do is we want to look specifically at what does a positive sloped line always resemble? And it is kind of nice because we get to say always today for these 4 tiling when it comes to the graphs. Don't always get to say always and never in math, but we do on this one. So make sure you have that sheet in front of you and let's take a look at this. So if we have a positive sloped line, that means that eventually m, once all is said and done, is a positive number, for sure. There's a couple of ways to do this, because remember, slope is a fraction. It's a comparison between 2 things. One way to do it is that maybe we have a positive rise over a positive run, because we know that a positive divided by a positive gives us a positive. That's one way to look at it. But there's another way for this to happen. And that is, what if we have a negative rise over a negative run? Well, we also know that a negative divided by a negative is a positive. So, but we still have that comparison of rise over run. There's something really nice about this. And this is going to hold true for us forever, which is really nice. If we take a look at the graph itself, we don't even have to put it in a specific location. So you don't even have to use the grid that's there. What we know about a positive sloped line is that reading from left to right, the line is going to start low and it is going to go up high. So it's going to look like the right side of the graph is pointing upwards. So I'm going to start low, so kind of down in this area somewhere. It doesn't have to be all the way down there, but can be. And we're going to draw a line that points up. Every single positive sloped line will always have the right side of the graph, so where the little arrow guy is, pointing up. So I'm going to take a look at this right side here, and I'm going to make that note. So right side points up, which is nice and consistent. It will always do that. So make sure that you have that written down. It's a nice visual indicator. So you can look at a graph with however many lines on it, and you can pick out the positive sloped lines immediately because you can see which ones are pointing up to the right. Okay, why don't you see if you can make a prediction for yourself about what you think a negative sloped line is going to be. And then let's figure it out. Okay, so negative sloped line is, well, it's going to be a negative value. In order for that to happen, could be a couple situations. We could have a positive rise over a negative run, because we know that a positive divided by a negative is a negative. Or maybe those are flipped around. Maybe it's a negative rise over a positive run. We know that a negative divided by a positive is also a negative. So we're going to get this negative situation regardless. Hopefully you have your prediction of what this one's going to look like. Well, in this case, it's going to look like it's been flipped from the positive. So we're going to start high on the graph on the left-hand side, and then the graph is going to go down to the right. So high on the left, point down on the right. Again, it's a nice little visual cue. You can look at it and go, did I get my slope right? Well, you'd have to double check the numbers, but you can also just take a look at, is the arrow pointing? Which way is it going? So it's the right side. That's what we're talking about here. So the right side points down. For sure. Again, nice and consistent. And I do keep talking about the right side because in future math classes, so when you get to some stuff that's a little bit more complicated with the graphs, we take a look at the right-hand side of the graph to try to figure out some of the other information about it. So you and I are just kind of laying the foundation for that right now. So make sure that you have that. Now, zero slope and undefined slope, they're a little different. So we're going to do the zero slope first. So if you have a slope that is 0, okay, that means we need to have 0 in the fraction somewhere. Okay, let's think about our knowledge here. We know that if there's a 0 in the top of a fraction, that we're going to get 0. So we know that we've got 0 rise, could have a positive run, but 0 divided by a positive number is just going to be 0. Likewise, we could have a 0 rise and a negative run. And even with the existence of the negative in there, we know 0 divided by a number, positive or negative, is still going to be 0. So ultimately what we have here is we have no rise, so there's no up-down movement to get to the points, but we do have run, so there is right-left movement. I think we have a flat line here. So I can look at my graph. We're going to have a flat line. So no rise, so no up down, but we do have left right. Now I'm not going to talk about what the right side of the graph does this time. I'm just going to talk about, well, what does it look like? Well, it looks flat. I'm even going to refer to this specifically as a horizontal line. So this is flat, which I'm going to call my horizontal line. So a 0 slope is flat. Just see if you can make a prediction for yourself with undefined and know that the 0 slope and the undefined slope, they have a relationship kind of like the positive slope and the negative slope do in that. Like, oh, if I flip it, then I'll get the other one. So make your prediction. Okay, so if this is an undefined slope, then we're going to say M equals undefined. I know that looks kind of funny, but we're going to talk about where undefined comes from. This is something you and I talked about probably about 2.5 weeks ago now, is the fact that if we have 0 in the bottom of a fraction, we get something that's identified as undefined. So if I have a positive rise over 0 run, this is going to be undefined. And we did go through and establish why we can't have 0 in the bottoms. Remember that division is just a fancy way to do multiplication. And if we want to do 0 times something to get a positive number, that's not possible. Likewise, if we're trying to get a negative number, let's say we have a negative rise over a 0 run. Well, that still can't be done. That's going to be undefined as well. Okay, so let's think about this. I have rise, so I have up, down, but I have no right or left. So if I'm thinking about a graph that only goes strictly up and down, I think we're talking about a vertical line this time. So you'll notice it has rise. It goes up and down, but it has no run. So we're going to say that this is a vertical line. So pretty important stuff on this first slide. Make sure that you have this recorded. Okay, so one of the next images on that images sheet for today. So we've got all of these graphs. Looks like there's A, B, C, D on this one. We're going to ask some questions here. So I want you to imagine that you are walking up or downstairs. Doesn't matter which way. And we want to think about the steepness of these lines. Now, the steepness has nothing to do with whether you're climbing up the stairs or down the stairs. Doesn't matter. It's just how steep is it as you are traversing it, so up or down. So if we take a look at these graphs, and we're going to take a look at lines A, B, and C specifically. I just want you to look visually and see, out of A, B, and C, which line do you believe is the steepest? So make a prediction. So which one would be the hardest one to climb if it was like a set of stairs or you were outside hiking? So which one would be harder to traverse? Yeah, I think it's B, and I'm getting that from people. This is definitely line B. Line B looks the steepest to me. Now, sometimes it's hard to tell. On the next slide, when we start doing some more practice, we're going to figure out, okay, how can I find exactly which line is the steepest? For now, we're just going to take a look at these visually and see if we can compare them. Okay, the least steep line. So B looks like a serious hike. It's pretty steep. So A and C are the ones that are the least steepest. So which one? Which one looks like it would be the easiest one to walk? Well, I think it's line C. I wouldn't say line C is flat because it's not, but it's definitely not as steep as A or B. Okay, question 3. This is kind of what I'm getting at. I want you to take a look at line D. And I basically want you to tell me, if we calculated the slope, because we're going to on the next question, would the slope on line D be positive or negative? So take a look at the right side like we did on the previous. So take a look at line D. You can also think about, if I was going from left to right on line D, would I be hiking up the mountain or would I be hiking down the mountain? And I think we'd be hiking down. Since we're hiking down, we would say that this would have a negative slope. So which way is it slanting from left to right? Well, it's slanting down. So what this is telling me is that I'm going to have a negative slope. Oh, well, what is the slope of line D? Okay, so I'm going to do some color coding here because I'm going to put some stuff on my graph. And I just want to make sure that I don't get it confused with the other lines itself. Okay, so with D, I like that they have like the little stair steps already put in. So I'm going to go ahead and follow those. So I'm going to choose 2 points on the graph, and I'm going to color code them red. So those are the 2 points I'm going to use. Now you can use any 2 points on the line that you want. You just want to make sure that it's not crossing at like a half or a third or like a decimal location where you'd have to guess. We want to know it's exactly at this point, so you can see the little grid on the graph. Okay, left to right. So starting from the red dot on the left, I would go down 2, so that would be -2. Then I would go right, it's positive, 1, 2, 3, 4, 5. So I think my slope for line D, so my slope, M, with a subscript of D, so I know which line I'm talking about here, is going to be down 2, right 5. And then we know that a positive divided by a negative is a negative divided by a positive is a negative. So there's my slope for line D. Okay, let's take a look at the other lines. Still going to stick with some color coding. So I think I'm going to take 2 dots on line A, and I'm going to color code them orange. So I'm going to go to line A, and I'm going to pick 2 dots. And I think I'm just going to pick 2 dots right next to each other this time. So I'm over on my graph, and I've got my 2 orange dots filled in. Okay, I'm going to do the exact same thing that I did before. I see that they have those stair steps there, but I don't want to use those. I want to do the up part first, so I know what goes on top of my fraction, and then I'm going to do the right part second, so I know what goes on the bottom of the fraction. So from the left orange dot, I'm going to go up 1. Then to get to the right orange dot, I'm going to have to go right 1. So down at the bottom now, up 1, so I've got a +1 rise. Right 1 is a +1 run. Now I know that a positive divided by a positive is a positive. I also know that 1 divided by 1 is just 1. So I think my slope for A, line A, is going to be a +1 slope. Okay, let's move on to B. I'm going to do the exact same thing. I'm going to go to line B. I'm going to choose 2 points on line B, that nice little corner. So there's a green point and there's a green point. So over on line B. I don't like the stair step looking thing. I'm going to do the up part first and then the right part second. So it looks like I have to go up 3 boxes. So that's going to be a +3. And then I'm going to go right 1 box. So that's a +1. So I'm down at the bottom. Rise of 3, so +3, over run of 1. 1 to the right, so it was +1. Simplify. I know a positive divided by a positive is positive. 3 divided by 1 is 3. Okay, line C. Now, don't worry. I got a whole bunch of practice for you on the next one. You can see it on the images sheet that you have in front of you. I'm going to go to line C, and I'm going to choose 2 dots, crossing it a grid. So I've got here, blue dot, and another blue dot. I'm not going to use the stair step that's there because I like the rise and then the run. So start at the left blue dot. I'm going to go up 1, so +1. Then I'm going to go right 2, so +2. So remember, the rise goes on top, up 1, over, the run goes on the bottom, +2, so I went to the right. I know that a positive divided by a positive is positive, and I can't simplify 1 over 2, so I'm just going to leave it as a half. So moving on, taking a look at this image, you'll notice that I gave you the points. For now, probably going to stop doing that pretty soon. You'll have to find them yourselves, crossing it a grid. We've got question 6 and question 7. I'll be honest, if it were me doing this problem, taking a look at this, I would probably have a hard time figuring out which one is the steepest. So I'd probably do question 7 first. So what I'd like you to do, and I'm going to wait, I want you to work on question number 7. I highly recommend color coding. So I'm going to give you a couple minutes head start on this, and then I'm going to slowly start filling stuff in so you can do the work and then look up and check and see if you and I are matching. So I started working on a couple of them. You can see my little stair steps that I'm putting in. So as you are working, go ahead and look up and see how you're doing. Okay, so double check your work against mine. I got all of question number 7 complete. Then I'm going to talk to you about how I personally determine the steepness, or which line is the steepest. So what I do is I go through and I calculate the slopes first. And I take my time because I want to make sure that I don't make a mistake here. And I did do a lot of color coding just because there's so many lines here. And I wanted to make sure I was using the correct dots. Now the steepest line, here's my trick. Ignore the signs completely. So don't look at the positive, negative part on your slopes. So first thing is I would calculate the slope. So calculate the slopes. Then, ignoring the signs, which line has, what number is the biggest for slope? So, ignoring the signs. Choose the biggest slope. That's how I go through and figure out which line is the steepest. So I have all of my slopes are done. I'm going to ignore the fact that there's positives and negatives in here because it doesn't matter to me. Because it doesn't matter if you're climbing up the hill or down the hill. We want to try to get the steepest one. The steepest one is the one that has the biggest number. Avoid the signs though. In this case, I think it's line A. And that's because out of all of the slopes here, 2 is bigger than all of the other ones. So I would say line A is the steepest.